Identify the hypothesis and conclusion of the following statement, and determine whether the statement is always, sometimes, or never true. So let's see what the statement is. We have x, well, this should be an x squared plus 5x plus 7 is greater than 0 for all real numbers x. So first, let's rewrite this as a bit of a proposition, as an if-then statement. And then it becomes a lot easier to identify the hypothesis and the conclusion. So we could rewrite this as if x is a real number, then this is true. Then x squared plus 5x plus 7 is greater than 0. And when you write it as an if-then statement like this, it becomes a lot easier to identify the hypothesis and the conclusion. Now, the hypothesis is really just what the if part is conjuring up. So this right here in pink, x is a real number. That's the hypothesis. Sometimes it's called the antecedent. That is the hypothesis. And as we said in previous videos, it's different, although related, to the notion of a scientific hypothesis. Here we're dealing with the hypothesis of a hypothetical proposition. Don't want to confuse you too much. It's what's inside of the if part of the statement. The conclusion is the conclusion from the then, or it's the consequent right here. Then that. That right there is the conclusion. Conclusion. We could have labeled this too. The conclusion here is this statement right here. That right there is the conclusion. That is what you conclude if x is a real number. So you could say for all, that is the hypothesis right there. For all real numbers x. That is the hypothesis. Either way you want to do it, it's always easier to write it as an if-then statement. Now, the more interesting question is whether this statement is always, sometimes, or never true. And the first thing that might pop out at you is that the coefficient on the highest degree term here, on the x squared term, it's a positive coefficient. So this is going to be an upward opening parabola. It's going to be an upward opening parabola. Let me draw that. So if this is the x-axis, right there, whether this is always, sometimes, or never true rests on whether the vertex, whether the minimum point of this parabola is above or below the x-axis. Let me draw it for you. So if the parabola looks like this, then for any x you pick, the value of the function, the value of x squared plus 5x plus 7 is always going to be greater than 0. If the function looks like this, then you're going to have some values for x where it's greater than 0, but you're going to have some values for x where it is equal or less than 0. So we have to determine whether it sits above, or maybe, I guess, on or below the x-axis. And that's the y value of the vertex. Now, we know that it's not never true. Because this is an upward opening parabola. Even if your vertex is a negative number, eventually, if you get far enough away from it, you're going to get to positive values of this function. So we know it's not never true. We just have to decide between always and sometimes. And to figure that out, let's figure out where the vertex, and in particular where the y value of the vertex is. But in order to get the y value, you need the x value. So the x value of the vertex, there's a formula here. I normally don't like giving formulas, but we've shown this in multiple videos before. It's negative b over 2a. And I can't help myself. If you look at the quadratic formula, it comes straight out of that. The quadratic formula is negative b over, well, I'll write it as negative b plus or minus the square root of b squared minus 4ac. All of that over 2a, or you could write it as negative b over 2a plus or minus this thing over 2a. You normally just see it with a big 2a in the denominator, but you could split it up like this. And notice, this right here is a formula I just told you is a formula for the x value of the vertex, which makes complete sense because the vertex is always going to be along the line of symmetry of our parabola, and it is going to be equidistant. It's going to be equidistant from each of the zeros. So you get a 0 in the plus direction. This is the distance right here. This is one of the zeros in the plus direction. And then if you subtract, that's the other 0. So it makes sense that negative b over 2a is the x value of the line of symmetry, or the x value of the vertex. Now, with that said, let's actually figure out what the x value of the vertex is for this problem. So we have x squared, so negative b over 2a. So this is equal to negative 5, because b is 5, over 2 times 1, over 2. So that's the x value. Let's figure out where it sits, whether the y value for the vertex is below or above the x axis. So the y value, we'll just have to substitute into this. The y value of the vertex is going to be equal to negative 5 halves squared. Negative 5 halves squared plus 5 times negative 5 halves. And then finally plus 7. Let's see if this is positive or not. So negative 5 halves squared is 25 over 4 minus 25 over 2 plus 7. And so we can add these. Let's put everything over 4. So this is equal to 25 over 4. 25 over 2 is the same thing as 50 over 4 minus 50 over 4 plus 28 over 4 plus 28 over 4. And this is equal to, well, we know our denominator is going to be 4. And you have 25 plus 28 is 53 minus 50 is 3. So it equals positive 3/4. So the y value is positive. It is above the x-axis. So the parabola will look something like this. The parabola will look something like this, where the y value is 3/4 for the vertex. The x value we just saw is negative 5 halves. And because the minimum point of this upward opening parabola is a positive number, the minimum y value is a positive number, it's always going to have values at that level or above it. So this is true for if x is a real number, then it is true. It is always true. It is always true that x squared plus 5x plus 7 is greater than 0.